has two arrays again. One is values, one is labels. Now each value corresponds to a label, each value corresponds to its label. So each index has a pair right now. Basically the linkage is a pair linkage. And now what we can say is that these are the numbers wanted and this is the usage limit. These are two numbers given to us. What we have to do is, this is the total and this is the limit of how many can we use of a particular number. So suppose there are these duplicate labels. Out of these two ones I can only use one. Out of these two I can only use one, because only the usage limit is one for me, and the total numbers that I'll have to choose is from each label I can choose one, right? And I need the maximum sum. Now to get this into picture, if somehow I can rearrange it, right now what do I have? I have a 5, 1, and then I have a 4, 1. I have a 3, 2, 2, 2, and 1, 3. So these are my pairs basically now, right? I want to just order them in such a way that when I start adding it, I should have the ability to even neglect some of these values, because if I reach this limit or this limit anytime, if I reach this limit, then though I'll just return whatever sum I have made till then. If I reach this limit, I'll just continue to the next value whatever is present, right? Now what I was thinking initially was that for each of the numbers, for each of the labels, what I'll do is, I will, for each of the values I'll get to whatever the priority queue is. So suppose if I can choose only one, right, I will have priority queues of length 1. So this will have the maximum element whatever is there on top. So I'll have a min heap so that I can have the maximum element related to that label. So for each label now I will have the number of these, and then each label will be stored in some form of a map, and then map I will iterate from the end. So the same kind of ability can be also given by a multi-map to me. That is why we can choose multi-map over here. What multi-map does is, so it will arrange it in such a way that 1, 3, 2, 2, 3, 2, 4, 1 and 5, 1 will appear, right? Now if we are, this is when we are taking the values into consideration. Values is first and then the labels is next. Now the other way to go around it was, if we consider this example, what I had to consider was like, first I would choose 3, then for 3, 2, 1, this is in the descending order first. This will be for 3, I should choose, these 3 values are present, 4, 3, 2. Now this will again be in the descending order. I need only these 2 values because the usage limit is only 2. And then for 2 I will make another priority such that it has only one element, so I don't care, it has only one. Now if there were other elements, right, similarly I would have to do a descending order in this way also. This also descending, this is also descending order. This is what I'll have to maintain to reach my answer. Now I will add these values until I reach the number nums wanted. That is my end goal. But do I have to do this much? I don't, ideally. I can look at it another way, that I'll just sort it based on the values. That is what we need, right? First thing is, based on values we are sorting it. So multi-map, what it does is, it will help me sort it based on values. Even if I take a pair, right, I could have also taken a pair of int, int and then sorted it. This will also give the same thing. But why multi-map? Because map is a self-sorted data structure. We don't need to even care about this part now. It will already give us the self-sorted part. Now it will already give us the sorted order. Now after doing this, I will get it in this order. I mean, the first it will be ascending, but then later on if there are duplicates, right, again it will be in the ascending order only. What I needed was descending and descending. What I'll do, I'll just iterate from the reverse. That is it. If I iterate from the reverse, I am ideally going from the descending order, right? And then if there are any duplicates also, that are also going in the descending order. I can just keep a frequency counter for each visited number label, because in labels we have a limit, again usage limit, that we can use only one, we can use only two. So we'll just look at the code now. Took a multi-map and a count array. It's not an array, it's a unordered map basically of count, which will just store this frequency, what I meant by. I'll just have an answer at the top, which I'll be returning at last. I will go through each of the values and labels, make the pairs, and then insert it inside my map. Now when I insert these values, right, in the multi-map uses mp.insert. This is also a point that we need to remember. We cannot do something like mp of values of I equal to labels of I. This is not valid for a multi-map, right? This is only of a make pair, and then we do this. This is valid and this is not valid. So now I'll just put it in that. After putting only, I'll directly get this self-sorted structure. I'm not telling that it will help in my time complexity, but I'll get the directly sorted value. How it will be sorted? Ascending and ascending. Then I just need to go from the last to the first in the reverse order. So I'll just iterate from R begin to R end. These two are basically the iterators which will help me traverse the map in this way, in the descending, and I'm keeping this count frequency map, so that every time I add something into the sum, every time I add something to the answer, what I do is I will do this key for each of the numbers wanted, this number, because maximum I can do this only, minus I'm just subtracting the number wanted. Now this also condition is in top only that I'm using. Key I just want till numbers wanted. If I have got like k values to be filled and I fill up k values, then I don't need to fill anymore. And in those k values also there is another condition, that for each of the count I can have only use limit values. Use limit, let us say it is n. So only n values I can have for each of the label, each label. So that I'm incrementing label for each label increase. This is the count, and this maintains my total count of the elements that I'm counting. This was a decent problem, just refreshing the multi-map concept. Thank you.